The aim of this presentation is to show a modification of the DMEK technique. It's called the Cannula-assisted ab-interno hydrounfolding technique. This technique has been conceived by Professor Sarnicola. I haven't got any financial interest to declare. So the DMEK allows a selective replacement of the diseased endothelium and descent membrane, and has garnered increasing interest along the last decades. Nonetheless, only the 11% of the total endothelial keratoplasms were DMEK in 2014 in the US. So this makes what Professor Perry questioned in 2012 still echoing. So why aren't all we doing DMEK? So one of the hurdles causing reluctances in facing and embracing the DMEK technique has been found in the scrolling and the attachment of the donor graft. In this paper, the unfolding and the attachment of the graft lamella was graded with regards to the difficulty of graft unfolding and attachment, and the authors concluded that there was a significant difference between the grading groups at any time post-op. Nonetheless, on the other side, the Strakes group described that once the DMEK tissue is safely into the anterior chamber, surgeons need not to rush the DMEK dumps because long-term scrolling times may not endanger the endothelium. So the question is, how do we unscroll properly the DMEK graft? So as for almost all surgical techniques, physics comes and helps. This is a physics principle, it's the Huygens principle, for which each wavefront becomes source for a further wave propagation. So you have a source from a wave, and once you get an interface here, the new wavefront becomes a new source for further wave propagation. And this is how the fluid dynamics rules the graft unfolding. So you can gently push at the center of the cornea, and this allows the passage of wave just beneath the curves of the graft. Or alternatively, you can firmly hold one part of the peripheral cornea, and then you can perform a tapping movements at the center in order to unroll the peripheral curve. So these techniques have mostly been described by Meller's group with the single-slided cannula maneuver with two cannulas parallel. So in this technique, it's like you're unfolding a carpet from with two cannulas. But what if you create a singular wave source and a directional current of a fluid inside the anterior chamber? So here you see that Professor Fogla and Professor Caporossi designed blank cannulas, provided bilateral openings with one opening at each side or three openings at each side. They're actually very useful when the surgeon is dealing with the double scroll configuration, the endothelium descent membrane graft. And here's what Professor Sarnicola developed. So he thought to design two irrigating blunt cannulas with the unilateral opening on the right side or at on the left side, and they are very useful to selectively unfold the graft. Here's the schematics. So the left cannula is used to unfold the left curve, and the right cannula to unfold the right curve. And here's, eventually there is another cannula, is the port up. This is very useful at the end of surgery because the cannula is still blunt at the end, but has an opening on the upper side of the cannula. This allows the air bubble to be injected selectively just at the center of the, under the center of the graft. So this avoids the displacement. This is the video. So the technique has been called ab-interno, so it means internal hydrounfolding in opposite to the external tapping movements. So there is the marking of the descemetorrhexis. There is a large descemetorrhexis here. And the graft is injected and gently pushed towards the center of the cornea. But the graft is very large when compared to the depth of the anterior chamber, so we have an inadequate discrepancy between the anterior chamber depth and the graft diameter. So here the graft is in the center of the anterior chamber, but again, if you hold the peripheral cornea and then you create tapping movements, you have difficulty in graft unrolling. So here comes you try to inject some BSS. Again, the graft is seen rolling into the anterior chamber. You have a DMEK dance. So this is the scroll. And here's the right port cannula. So the right cannula is inserted through the lateral right paracentesis. You can observe the Mutsuri sign that confirm a correct orientation of the graft. And here's the technique. So you inject a BSS under the perival curve, and this unfolds the right curve. Then use the left cannula. You insert through the same paracentesis, in this case, and then there is a wave of fluid just beneath the left perival curve of the graft. So here it is. Then you center the graft. This is the positioning. And eventually, here's the port-up cannula. So just go under the very center of the graft and inject a bubble of air without the risk of dislocating the graft. Many thanks for your attention.